Welcome back to Pre-Algebra Chapter 5, Section 4 in this book. And what we're going to be doing today is multiplying fractions. When you were in elementary school, adding was easier in subtracting than when you got to multiplying and dividing. But with fractions, it's actually easier with multiplying. The hardest part of fractions is the last tape, where you're adding and subtracting mixed numbers, unlike denominators, all that. Multiplying is much easier. So, how do you do it? Well, you just multiply the numerators, I almost didn't say that, and then multiply the denominators. So when I was first learning this, I would draw little arrows to remind me of that. 3 times 1 is 3, 5 times 4 is 20. See, I told you it was easier. Let's try it again. 3 times 4 is 12, 5 times 7 is 35. Easy! Alright, how about this one? Now, this one, you could do it. 7 times 4, negative 4, 10 times 21, and do it straight over and get the answer. But then you'd have to reduce it. And if you can do what I showed you before, of converting numbers into their factors and crossing out, it's fun and a little bit easier. So 10 is made out of 2 times 5. 4 is made out of 2 times 2. 7 is prime, but 21 is made out of 3 times 7. When I convert a number, I mark it out so it doesn't confuse me and I don't think it's there anymore. Now I look, and if anywhere in numerator land matches anything in denominator land, you can mark it out. So I have a 2 here and a 2 there, those can mark out. I have a 7 here and a 7 there, those can mark out. So what am I left with? Well, I'm left with a negative symbol and a 2 for the numerator, and I'm left with a 5 times 3 in the denominator, which is 15. Ta-da! I really like that. There's something very fun about that for me. Alright, now this one, isn't that ugly? First of all, that's not even a fraction. How are we going to do that? Well, we make it a fraction by drawing in the understood 1. Now that thing, that doesn't look good, does it? We're going to have to convert it to an improper fraction. That's why I said they need to be renamed, because this is improper for this problem. What's proper, good, and right is an improper fraction. So, and how we do those, I call a C problem. We had our Z problems, these are the C problems. You multiply, 4 times 4 is 16, and then you add 16, 17, 18, 19. So that's 19 fourths. The denominator stays the same. How you get the numerator is you multiply, then add as you go around the C. So I'm going to rewrite this times 63 over 1 there. So that was just all messy. We'll put our 63 over 1 up here. There, that looks better. Now, is there anything I can mark out? 4 doesn't go into 63, it goes into 64. 19's prime. I think that's it. Let's cheat and look in the book and see if there's anything we can mark out. Nope. So it is you just multiply across, and of course you would do this on your calculator unless you know your 19 tables up to 63, which I doubt because I don't. It's 1190, I'm being dyslexic here, I'm writing it backwards, 1197 over 4. Now, in algebra, that is considered the answer, but because it's pre-algebra, they like mixed numbers. You're not going to have to do this ever again, I think, once you hit algebra. So that's the answer that they would have in the back of the book. Okay, with this one, we need to do 2 C problems. So, 4 times 2 is 8, 9, 10, 11. Negative 11 fourths times, and I do this every time. Every time I draw my C. 3 times 5 is 15, plus 1 is 16. It helps keep in my brain what I'm doing. Now, can I cross anything out? Yes, I can. 16 is made out of 4 times 4. So those 4's can cancel out. That looks like all I've got. Negative 11 times 4 is negative 44. 5 times nothing is 5. And there it is in proper, and I'm sure they would properify it. That's a word, right? Now what about if there's a letter? You do it the same way. 12 can be made out of 3 times 4. These 3's cancel out. What do I have left in the numerator? An m, a negative sign, and a 4. So it's negative 4m, and the denominator is 5. Ta-da! Here's some more letters. Can I do anything here? Yes. 10 becomes 2 times 5. The 5's cancel out. I can't cancel out any n's or the 9's. So what do I have left in the numerator? I have 5 n's. 2 and then 3 more. I have 5 of those. And in the denominator I have 2 times 9, which is 18. Ta-da! And that's definitely an Algebra 1 level problem. And so is that one. But I think y'all are smart and can handle it. But if that actually freaked you out, just pretend it doesn't exist till next year. Alright? Math is great. Yay!